Today we are going to look on logarithms, and we are first going to talk about the laws of logarithms before we get into our examples. So the first law, what you should know is, you're given the log of a with a base of a, it means that that equals to 1. So if you're given log 10 with a base of 10, it means that the answer is 1. The second one is the log of a base b plus log of c base b. It implies that the answer will be log base b a c. So what about log base b a plus log c base b? I mean, this should be subtraction. It means that we will have log base b a over c. So what we see from these two laws is that multiplication, or in multiplication, implies that we add the logarithms, and division implies that we subtract the logarithms. So what about if you're given the log of b with the power n and it has a base of a? It means it will be log n log a b, and also log b base a can also be written in the form of log b a. You can also have another one here that says that the log of base bc equals to m. So b over a equals to c. Let's start our first example. So you've been told, solve for x in here. We see that both these logs have a base of 10, and here we have minus 1, so it's not in terms of logs. So we try and write it in the form of logs, whereby we will write it as log base 10 6x minus 2, and we saw that 1 can be written in the log of log 10 base 10 equals to log 10 x minus 3. So where we see we have subtraction, it means that we divide, and what's common in this part of this equation is log 10. So we write log 10, then it will be 6x minus 2 over 10 equals to log 10 x minus 3, which is in bracket. So this log and this log cancels out. You're left with 6x minus 2 over 10 equals to x minus 3. So we can multiply this side by 10 and this other side by 10. So this 10 and this 10 cancels off. You're left with 6x minus 2 equals to 10x minus 30. So we bring this 10 this side, so it will be 6 minus 10x, it will be negative 30 plus 2. We are left with negative 4x equals to negative 28. So this and this becomes a positive. Our x remains as 7. Let's try another example. So you've been given log 10 minus 2x minus log x plus 5 equals to 3 log 2. So you can see that this is subtraction, so it means that we have to divide. We will write it as log 10 minus 2x, and log is common in both. Divide by x plus 5 equals to log 2 cubed. This coefficient, we bring it up here, so it becomes as a power. You're left with this log, and this log cancels out, so you're left with 10 minus 2x over x plus 5 equals to 2 power 3 is 8. So we multiply both sides by x plus 5 and this other side by x plus 5. So this and this cancels out. You're left with 10 plus 2x. 10 minus 2x, I mean, not plus. 10 minus 2x equals to 8 into bracket x plus 5. So 10 minus 2x equals to 8x plus 40. We bring this 8 on this other side, so it becomes minus 8x equals to 40 minus 10. Negative 2 minus negative 8, you're left with negative 10x equals to 30. So our x will be negative 3. Our third example, so 2 log base of 10, 5, subtract a half, log base of 10, 16, plus 2 log 10, 40. So we are going to remove this coefficient and make them as powers. So it will be log base of 10, 5 squared minus log base of 10, 16 power half, plus log base of 10, 40 squared. So when you write it, it will be log base of 10. When we see subtraction, it means that we have to divide. So it will be log base of 10. When we square 5, we're left with 25. 16 power half, it remains as 4. Plus, where we see plus, we write it as multiplication. So 40 squared is 1600. So by 4, 1 by 4, 400. So 25 times 400, we are left with the log base of 10. 25 times 400, it's left as 10,000, whereby log base of 10,000 is 4. So our answer will be 4. Let's try another one. So find the values of y which satisfies the equation. Let me write it. Which satisfies the equation log 2y minus 11 minus log 2 equals to log 3. I mean, it should not be a base, it should just be a number on its own. So log 3 minus log y. So as we can see here, we can just write it log. On this side there is subtraction, so we have to divide. So it will be 2y minus 11 over 2 equals to log 3 divided by y. So this log and this log cancels out. You're left with 2y minus 11 over 2 equals to 3 over y. So we can multiply both sides by 2y. 2y, as well as this other side multiplied by 2y. So when we multiply this side by 2y, we are left with 2. We are left with y alone. So in this other side, we are left with 2. So our equation will be y multiplied by 2y minus 11, which will be equals to 6. So it will be 2y squared minus 11y equals to 6. So this is a quadratic equation. We have to solve it. Equals to 0. So this and this. Our product will be negative 12 and our sum will be negative 11. What number can we multiply with to get negative 12 and the sum to be negative 11? So it will be negative 12 times 1. Negative 12 plus 1, we are left with negative 11. So it satisfies the equation. So we can write it as 2y squared minus 12y plus y minus 6. Can be left with 2y, y minus 6 plus y minus 6. So 2y plus 1 equals to 0. Our 2y will be negative 1. So the value of y can be negative a half. Yes, and it can also be y minus 6 can be equals to 0. So the value of y will be 6. And that's the solution to that question. Let's try another example. So log base 4 x squared, so this whole log is squared, plus 3 over 2 log base of 4x equals to 1. So we can see that all these logs have a base of 4 and also x. So it is log x base 4. So we can write it as log x base 4. We can say that it's y. So when we come here, we'll just write it as y squared plus 3 over 2y equals to 1. Let's get rid of this 2. So we multiply each and every side by 2. We are left with 2y squared plus 3y equals to 2. So it's a quadratic equation. We try and find the value of y. So 2y squared plus 3y minus 2 equals to 0. So our product will be negative 4 and our sum should be 3. So what number can we multiply with to get a product of negative 4 and a sum of 3? That's 4 times negative 1. So we can write our equation as 2y squared plus 4y minus y minus 2 equals to 0. So it will be 2y to brackets negative y, 2 plus 1 negative y negative 2. So 2y plus 1 equals to 0. That means our y will be negative a half. This should also be a negative. So this is a positive here. And negative y minus 2 equals to 0. So the value of y should be negative 2. And as you can remember, we saw that the log x base 4 equals to y. So it's just like saying the log x base of 4 equals to a half. So it will be 4 a half equals to x. x, whereby our value of x will be 2. What about the other one with negative 2? So log x base of 4 equals to negative 2. So just write it as 4 negative 2 equals to x, whereby our value of x will be 1 over 16. Our last example, log base of 864 plus log 64 base of 4 equals to, we can say here, let's say 864 equals to a log 64 base 4 equals to b. So if we have our equation as this, as the way we have written here, it means that we can write it as 8a equals to 64. So the value of a will just be 2. The same to this other side, 4b equals to 64. So the value of b will be 3. So it will be 2 plus 3 equals to log x base 2. So 5, so it will be 5 equals to log, so it will be 2 power 5 equals to x, and the value of x will be 32.